2 seconds up to 9.69 seconds. What was my average rate of change then? Let's make this blue. What's my average rate of change from 2 seconds to 9.69 seconds? Now, please realize, friends, why I'm using 9.69 again. Why is that such a strange number? It's a very strange number. I was saying 2 here, and then 9.69. Remember where that came from?
Oh, because on the line. Because on the line it thinks that you started after.
Right. Well, just the best fit curve thinks it took me 9.69 seconds, and I did on average. On average, it took me 9.69 seconds to go 200 feet. Now, Jury's saying something else that I'm very, very happy to hear. She said that if you actually look at 0, time equals 0, the curve doesn't think I was at 0 feet. It thinks I was at 0.6 feet. I just pretended that was 0 to make life easy. That's worth ignoring. So, and we're going to have to avoid it here anyway. So, what's my average rate of change? Now, first of all, can you see it on the graph? Let me see if I can make you guys see it. If you can't. Can you see? Okay, here's the curve. The red line is my average rate of change from the whole trip, 0 to 9.69 seconds. Can you see what my average rate of change line would look like from 2 seconds to 9.69? First of all, find 2 seconds. Find 2 seconds. So that's 1, that's 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2. There's 2 seconds right there. So what we're going to be doing is we're going to be finding that, which is up off the x-axis a little bit, and connecting it to that. Is my average rate of change faster, according to that line, than it was for the whole trip? Yes, yes. And here are some votes for yes. Actually, I got 4 yes votes on this wall. That's kind of fun. Did you guys see? If I change my frame of reference, instead of 0 to 9.69, 2 to 9.69, my average rate of change just kicked up a little bit. Less time, but more distance in less time equals faster. More distance in less time equals faster. Hopefully that makes sense. I'm not losing much total distance by starting here versus starting here. But I'm chopping off 2 whole seconds. That's essentially 20% of the time. So a small percentage of the distance and a chunk of the time means it's going faster. Huh? These are my friends after their smoke break. Get in the exit really quickly. Cool? Yeah. Fair? Maybe. Okay. Let's crank the math to make sure we can do it. Now for those of you that are getting a little freaked out, you're like, I got to do total distance over total time. Don't worry about it. Total distance over total time.
Didn't you just take
Yes!
9.69 minus?
Yes! How much time is in that interval, friends?
Not as much as the other one.
Well, give me, but how much? Good answer, friend. Good answer, friend. What is the color purple? It's not orange. It's 7.69 seconds, right?
Yeah.
Right, it's the difference of the 2 times. From 2 to 9.69 is 7.69 seconds. So that's the total time we traveled. 7.69 seconds. Beautiful. Watching you, boy. Well done, well done. How much distance? Same idea.
You take off the first little.
Yes. Thank you. Thank you. Ashley's got it. What we have to do is figure out where we were 2 seconds, right? What's the easiest way to do that, friends?
Put 2 in your little calculator.
Easiest way I found to do that is to go to our TIs. We're pointing to the right place, yes. Go to your TIs. Okay, we're seeing it. Go to the table. Figure out 2 seconds. Oh, we already got it in there. Look at that. 7.78. There we go. We had that from before. That's the amount of distance we covered up to 2 seconds. The total amount of distance was 200 meters, right? 200 meters, if we're using that 200. So we take 200 minus this, and that's the distance I covered, yes? 200 minus that, fair?
Yeah.
So 200 minus 7.78, is that right?
Yes.
About 192.22. Michael's got it. Yes? 192.22 feet. Okay with that? Decent with that? Okay.